Let's go here. See that it's really streaming. Yep, it's really streaming. Wonderful. Okay, so hi everybody. Today I'm gonna solve a nice coding challenge that I found online. So here's the coding challenge. Maybe I'll make the screen a bit bigger. What do you guys think? View, zoom in, view, maybe another zoom in. Okay, wonderful. Okay, so this is what we're gonna be solving. Good morning, here's your coding interview for today. Given the root to a binary tree, implement serialize root, which serializes the tree into a string, and deserializes, which deserializes the string back into the tree. And here's an example. So let's start writing code. So let's call it third, and let's first here the class, and here's the example logic. And I want to write serialize, and that takes a node. Yeah, so the way to do everything with trees, honestly, is to write a recursive solution. So I'm thinking how I want to serialize a tree node, and first I want to write and I'm gonna use net strings, and net strings are a pretty nifty format. I'm gonna be using Python 6, so I can do this dot string. Let's comment these guys out. And print hello. Let's see if that works. Oops, I have Python 3. Python 3 third. Oh, because I named it wrong. Course. Okay, this is why it's nice to kind of, and so net string is a pretty nifty format because it nests well. And what I mean by nest well is the following. So, and the other thing is that because it always starts with a number, you can easily distinguish by the first character if something is a net string or not. And one trick is to notice that left and right are either none or strings. Right? So when you serialize a node, you can do this. Okay, so now let's do def NSO none. Okay, and that's a nice helper. Okay, so when you serialize, we always know that we have to serialize three things, right? And that's No, I don't think I need that. Serialize node. Don't think I need that. Let's see. Okay, so I'm gonna first ns of node.val, which is prefix, and now if self left is null, see what I want to do is here, if node is none, return n, else return and that's not self, that's node. Look. Okay, so now let's print serialize node. Let's see how that looks. And of course here I need string n. Okay. So you see the pattern. There's always something at the root. No, I don't think that is enough information to I think I need this. Yes, that's what I need to do. Okay. Yes, that's more like it. So there's always a root, and then the next thing is the left node, and the next thing is the right node. So and I think we want string IO. For deserialize, deserialize. String. What I want to do is I want to return deserialize fp string IO string IO string. And what do I want to do with that? Because this allows me to have a pointer into the string. That's very easy. And we'll do this. val left right. That's it. Okay, cool. So this is what I meant by net strings nesting. You can put a net string in a net string. Let's actually make this net string. Yes, net string I suppose. Okay. And now we need to implement read an s or none. And this goes like this. If there is not an old string, it's none. Otherwise, this means we are reading characters until we encounter a colon. Now length is convert this to integer, and now value equals fp.read length. Now fp.read comma read 1 if comma is not a comma, there is value expected okay, so this is going to be a little test. Okay, we'll do the third later, but let's see. Oh, 29. So it seems like we've read past the end of the file. So I think we need some prints in the Serialize FP. Trying to deserialize n. we know this should deserialize into, this should deserialize into a none. Opa. So this is simple test case. Okay, so let's see what's going on. We'll get to line 30. Got C. Okay, where does it go? Another one. Got N. Read an S or none. Okay, so let's see. Okay, now let's deserialize our actual thing and let's see what we get. And now let's remove the print statements. And we have the assertion. Right, so the assertion is that when we deserialize and we check the left node, we got left. So let's move this logic back here so that it's more obvious. And okay, let's look at our code and see what we have. So we have the class node that we didn't work at all. We literally copied that out of the problem. But now we have NS, and when we serialize, we get none. And when we deserialize, we go through this thing, which gives us a file pointer. And let's reorganize the code. Okay, so okay, so the serialization code, as is often the case, is very simple, right? We basically have this, which is just net stringify, and we have node, and if the node is done, we just return an N, and otherwise we net stringify the left and the right and the value and return it. And deserialize, we just ask for a string with a pointer basically, and then we read what we have, and if it's a value it will have always two children. There might be none, but they're gonna be children. So we read n also none, and then the children need to be deserialized, so we call deserialize on the children, and finally we return the node, the value, the left, the right. Reading a net string is this logic, except we have this little twist that if it's not a net string it returns none immediately, and then we just loop as long as we don't see a comma. We calculate the length with the length, with the comma, make sure it's a comma, and return the value, and that's it. Now notice the interplay here. This is called Deserialize FP, and after we're done, this actually calls Deserialize. It's left right here. This is fun, right? This is interesting, and that's it. That's all we have to do. Thank you, and enjoy. And now we go back. Bye everybody. We're gonna stop the stream now.